Before we write any code, let's picture the two data formats a pipeline meets everywhere. On one side is CSV, plain rows of comma-separated values, like a spreadsheet. On the other is JSON, structured records where every value has a name. A data engineer constantly reads from both. Keep this picture in mind. CSV is flat rows, JSON is named structure, and the code will make instant sense. Let's read CSV. Python's built-in CSV module does it with no extra libraries. DictReader turns each row into a dictionary keyed by the header names. We read from an in-memory text buffer here, so it runs anywhere, but a real file works the same way. Watch each row come out as a clean dictionary. Here is the trap that catches every beginner. When the CSV module reads a value, it is always a string, even numbers. The age you just saw came back as the string 30 in quotes, not the number 30. If you try to do math on it, it breaks. So remember this before we prove it. CSV values come out as text, and cleaning them up is the transform step's job. Let's prove it. We grab the age from a CSV row and check its type. It's a string. To use it as a number, we convert it with int. That one conversion is the kind of cleaning a real pipeline does on every field. Writing CSV uses DictReader. We give it the field names, write the header row, then write each record. We write into a text buffer so the date runs on its own, but pointing it at a real file works the same way. Watch the clean CSV text appear. JSON is friendlier for structured data because it keeps types. Picture a record going through a round trip. Turn it into JSON text, then back into Python, and the number stays a number the whole way. That is the big difference from CSV. Now let's see that round trip in code. The JSON module has two main calls. Loads turns a JSON string into Python objects, and dumps turns them back into a JSON string. Notice the age stays an integer through the whole round trip. No manual conversion needed. When a dataset is too big to load all at once, one handy format is JSON lines, or JSONL, one JSON record per line. You read it line by line through a small window, processing each record and moving on, no matter how long the file gets. Picture the robot reading one line at a time from an endless scroll. It is one of several ways to work with large data, and a great one when you want to stream records. Here it is in code. Here we read the JSONL one line at a time. We parse each record, use it, then move on, keeping only a running count and the last ID, never the whole list. That is exactly why this pattern works on a file far too big to fit in memory. Only one record is ever held at a time. So now you read and write the formats a pipeline meets most. CSV for simple rows of text, JSON for structured records that keep their types, and JSONL when the data is too big to load at once. Choosing the right one for each step keeps your pipeline simple and fast.